Okay, guys, I am back at it with the second video reviewing your Chapter 1 review, which we're going to count as your test. I look different. I had to take practically a 24-hour break to recover from all that math from yesterday. So I am ready to roll full speed ahead. I want to help you be successful on the back half, problems 35 through 54 of your review for Chapter 1, which again, we're counting as test grade. So I want you to be successful in that area. So stay tuned, buckle up. If you're actually paying attention to my videos, then I'm going to do a little extra surprise for you here. I know that by this point, watching the second video, moving my camera around, by this point of watching videos, you should be technically finished with all the way through 34. But as a little bonus for you, if you're paying attention and you're with me, I think it's only fair that I do problem number 33 for you, or with you rather. You can go back and check it, and if you missed it, you can fix it, and then you can get the point on your test. But I decided, the kindness of my heart, that I would work one of the 4 more difficult problems, which is 31 through 34, and I thought it would be nice to do 31 for you, and then we'll jump into the second half of the assessment. So you can check yourself to what I do and see if you end up with what I have. So 33 says 3x plus 4x squared minus 2x squared minus 5x plus 6. I'm just going to confirm that I copied this down right. 3x plus 4x squared minus 2x squared minus 5x plus 6. Fair enough. So in a problem like this, all I'm really having to do is simplify. So the way I'm going to simplify is just combine like terms. So again, you can think of the please excuse my dear Aunt Sally, because it really kind of all goes back to this. It just always does. And as you can see, there are no parentheses, so I'm done. There are some exponents, but really, if you think about it, so what would this do me if I solved this exponent? What benefit would it give me? This would just be a 4 times x times x. And since I don't know what x is, it really doesn't make sense to mess with this variable. So I'm just going to leave everything intact right now and just let it ride out and see what happens. Of course, I should draw my x back. There we go. So I'm not going to mess with my exponents right now because there's no math to be solved. It's like having, like a -8. I'm showing it over here to the right side. It's like having a -8 in parentheses and saying, yeah, there's a parentheses there, but there's really nothing to do with it, so it doesn't really count. And that's kind of how these exponents are attached to the variables. There's really nothing I can do with it since I don't really know what x squared is. There's no multiplication, and there's no division. So truly, I'm just to the last step, which is this addition and subtraction piece. And remember, we always go from left to right. So when talking left to right, I have to have things that are alike in order to combine them or simplify them. So I just need to start with what's alike. So I'll start here, 3x. 4x squared is nothing like 3x. 2x squared is nothing like 3x. And a -5x is like, it is similar to a 3x. So if I just combine these two dudes, then I'm going to get a -2x. Okay, fair enough. I've combined something easy. Okay, the next one I'll deal with is my 4x squared and my -2x. So if I have 4x, 4 times something that is squared, and I subtract 2 times something that is squared, I'm just going to end up with a +2 times something that is squared. And then this poor little dude, he's all by himself. He really doesn't have anything that's similar to him. So he's just going to get copied down. Now, the only thing that I should do different is really we like to number these in order of the exponent. It just kind of tells us a little bit about what type of equation we're dealing with. Later on, you'll understand that a little bit more. But we want to list them in descending order. So 2x squared is going to go first because this is a 2. And then this is the invisible 1, so it's going to go next. And notice it's a -2x. And then a +6. I don't really have to put this plus sign out in front of this because it's just assumed that it is a positive considering it's the first digit out front. So I'll just go ahead and erase that so that it's not confusing for you. So the final answer is 2x squared minus 2x plus 6. And that's just your total freebie if you're willing to watch me for the second half of the test. So there you go. That's on me. Okay, now we literally are on the second half of the test. And I'm going to start with problem number 35. I'm going to solve a couple of these and then turn you loose. And hopefully you won't have any problem working these. So the directions say express each of the following algebraically. Do not simplify expressions involving variables. So if there's a variable intact, just keep the variable intact. It's not that big of a deal. So we just need to read it and see what it's asking us. And a couple of these in the beginning are asking us multiple things, so we're going to have to answer multiple things. The first one says, what is the cost of 5 colas at 50 cents each? I hope that you can figure this one out, okay? You have 5 colas, and each cola costs 50 cents. I'm going to go ahead and just write it like a decimal because this is the best way to represent money. So literally, if I do the multiplication on this, I can even use a calculator. I can put 5 times 0.50 into my calculator, and I'm going to end up with 2.5. And I hope that you realize that's $2.50. So this is your first answer to number 35. Okay, $2.50. That's easy. The next step says at X cents each. Okay, so what's the cost of 5 colas at X cents each? So the first time I had 5 times 50. Now I have 5. Look, I'm using an old school multiplication number. And it says X cents. Well, I don't know how many cents that is. But I can't just say 5 times X because this could be like 10. It could be 10 cents. And then if I say 5 times X equals 50, that's not right. It's not $50. That's dumb. I can't do that. So I have to figure out something else to represent cents. And the way I do that is I just simply show 1 cent and I put an X at the end of it. So now if it's the X represents 10 cents, then 10 times 1 cent will be 10, and that will give it to me in a cents, because remember the word for 35 is at X cents, C-E-N-T-S. So I represent it by just multiplying X by 0.01, which is a penny. So easy peasy. This answer, it's pretty easy. My final answer for this one is just write it out like this. 5 multiplied by 0.01 X. And since I don't know what X is, I can't give a final number like I did in the first part of this problem. Okay, then it goes on to say, what is the cost of N colas at X cents each? Well, now I want you to replace this 5 with an N. So I'm going to say N times 0.01. When you have these questions that like stack questions after questions, most of the time they're just asking you to change one thing as you move down. Notice in the first one here, I started off with, just 2 numbers. Okay. Then in the second one, I was still going to buy 5 of them, but then I changed how much they cost. And now in the third one, I'm changing how many I'm buying, but I'm not changing how much they cost. So if you can get the first one correct, you can usually just build on it. So this says N times 0.01X. So the best way to write it is just put the numeric coefficient out front because most people like it that way. 0.01 N X. Now you might ask, like, well, why did you put this in a different order right here? Because why didn't you put, N times 0.01X, like the 5 was up here? And you can actually do that if that's the way you want to show it. But most of the time, we know that you can take A times B times C, because remember all those properties that we just covered? And it can also be A times B times C. And we just talked about that. 10,000 bonus points if you can name it. Totally kidding, but it sounded good and you probably all got excited. But we know these properties exist and we know that we can use this line of logic. And so the only thing that we did was just rearrange the things that we were multiplying. And typically speaking, we like to put our variables, the letters, in alphabetical order. And since N comes before X, we just write it that way. 0.01 is the numeric coefficient. N and X are both variables, and we like to list N first because alphabetically it's first. And then it says you give your answers in terms of dollars, which, by the way, I did. This is a dollar, and these are as close to the dollar representatives as you can. So there you go. There's your answers for number 35. So you're welcome. And hopefully you can just carry on that same line of logic for 37, 38, 36, 37, 38. I'm going to go ahead and do problem number 39. So you should pause me again. And when you get finished with 38, you should come back to me. Okay, hopefully you finished all the way through 38. If not, you just get to listen to me pause and keep right on moving. So let's go through number 39. It's a little different than the money scenario. This is probably the last one that I'll work for this section. So the word problem ones, this is probably the last one I'm going to do. It says Amy Brown was married when she was 26 years old. Okay, easy. How old will she be after she has married for 5 years? So she's married at 26. We are going to add on the 5 years, which is going to give you a whopping grand total of 31 years old. So you might say she's 31 years. Okay, that's the very first answer to this, looks like 3-part question. Then it says, how old will she be? Oh yeah, after she's been married for 5 years. Okay, how about for X years? So we say 26. And remember how I told you, you typically just replace like one thing at a time. So the only difference here is that you're going to replace, instead of having 36 plus 5, you're going to have 26, my bad, 26 plus 5, you're going to have 26 plus X. So you're just changing the fact that before we knew she had been married for 5 years, and now we don't know what it is. So this is it. This is all you put for the second half of the problem, second portion. For the last portion of the problem, it says, how old was she X years before she was married? Well, if she started off when she was married, she was 26, and we want to know how she was 5 years before she was married, then, or X years rather, before she was married, then I literally just subtract the X. So the last one is 26 minus X. It's really that easy. I think these are silly, silly simple. So again, this is pretty much the gist of that section. So finish out on your own 40 through, looks like 46. And when you are finished with that, come back to me and I will be working another problem. Okay, awesome. Now I'm on 47. I'm just working 47 first because it's the first one of this section, and they're all pretty similar. So if you can start with the first one with me, hopefully you'll be more successful all the way through. It says translate each rule into a formula. So I'm just reading a rule and writing it basically as an abbreviation. Remember, if I'm translating into a formula, if I was to write out as soon as possible and I translated it to ASAP, that's really kind of what you're doing here. The volume V of a box whose base is a square. Okay, so I'm working on the volume of a box, and I'm just going to draw this because the base is a square. I am not an artist, and I'm not even 100% sure I can draw a box. I'm questioning the desire to draw this, actually. Maybe. I'm not going to say it's the world's best box, but I sort of feel like we're getting there, don't you guys? Like it's actually starting to look a little bit like a box. If you're an art major, I'm embarrassed right now. Oh, this one is not really lining up. This is not the world's best box, but you know, we're kind of there. Oh, shoot. I knew that was going to happen. Okay, so it's an ugly box, okay? We're all just going to accept the fact that, oh, snap. Gotta make something better, and it's just not happening. You can totally crack on me for my inability to draw a box. Oh, and I forgot there's missing a piece. Okay, close enough. We're going to call that good enough. So there's a box, and we're trying to fill the volume. So the volume is like if you were to completely fill the entire thing with like water or sand or something, then that's what you're looking for. The volume is just totally filling it all the way up with stuff. Okay. So this box who is a square. So this little dude's actually supposed to be a square, which means that this side and this side are the same measurement. It clearly doesn't look that way on my drawing, but it is true. And we're calling these S and S. So because it says side and side. So we're just calling them S for side and side. And whose height is H. Now, this is supposed to be the height. This is like how tall it is, and we're going to call this H. So all we're really trying to do is find volume. Well, if you were to Google, how do I find volume? Then you're going to get like base times width times height, which is pretty much dead on what we have right now. So if we're substituting in the information they gave us, then the base is going to be like this dude. So we're going to call this S. And the width, how wide something is going to be this dude. They just both happen to be called sides here because it's a square and they're both the same as measurement. So we're just going to drop that one in. And then the height, well, that's the easiest one of all. It literally just says H for height. So now all I have to do is just clean it up. I have S times S, which hopefully you know that S times S is the same as S squared. So I have V, and the way they like the problem to be written is the letter, usually in alphabetical order, but because this one has a 2, because it's squared, then you want to put that one first, because remember we put the highest exponents first. And then we have H. Oh, looks like an N. Okay, so V S squared times H. And that is literally how you do number 47. Okay, that only leaves us with 53 and 54, and I'm going to do 53, but not until you go away, pause me, and come back after you've completed through 52. Good luck. Okay, 53. More drawing. Okay, so I have a square. It's not a good looking square. And both of these sides are called W. And just to prove that this is completely an accurate to-scale drawing, I'm going to go ahead and put my little right angle symbols in here. And all this is doing is proving that this actually should have been a complete square. And then in the middle of this dude is a circle. That actually looks better. And here's the radius, and radius stands for R. So the part that I'm trying to figure out, oh man, I'm totally meant to change that to yellow. So the part that I'm trying to figure out is all of this. I have some serious artistic skills right here. So I'm trying to figure out what the volume, what am I trying to figure out? Oh, the area for everything that's shaded. Okay, so this is insanely easy, maybe. So the first thing I need to do is figure out the area of this square. And I know it's a square because this side is worth W and this side is worth W. And so if I'm figuring out area, it's usually length times width. And in this case, they're both W and W. So it's W times W. And then we know that W times W is actually W squared. So that's the entire box. The problem is that all of this nonsense on the inside, whoa, we got to take this off. So we have to get rid of that. So we're going to have to take whatever this is, and we're going to have to subtract off all the stuff that's inside of this circle. Well, that's fine. We just have to figure out what the area of a circle is. And lucky for me, I happen to know that the area of a circle is pi times radius squared. Now, the cool thing is that I don't have to replace anything at all on this because they told me that the radius stands for R, and I'm literally using R already, so I don't even have to do anything. So all I have to do is say, take this, the whole thing, and subtract off this, the circle hole in the middle, and I'm going to have my final formula. So the final dude, real big, is A equals W squared, that's the box or the square, minus pi times radius squared, which is the formula for the circle, boom, that we're cutting out in the middle. So that is the answer to 53. Okay, so you only have 54 left to do. If I am not the coolest teacher, I really don't know who is, because I've completely worked through most of this math assessment with you. You should be able to rock this out. Do not leave math this week until you know this stuff for sure. If you don't know it, please send me an email and let me know. I will shoot you another handy dandy video and explain it to you. So make sure you are squared away. Rock out this test, get all of the points, do a few extra on 1.9 and 1.10 to scoop up some extra credit. Some of you are really good at that, by the way. And then next week we will begin chapter 2. Enjoy the week, folks. I will see everyone soon.